The Brenner Pass on the border of Austria and Italy connects the countries of northern and southern Europe. The highway here runs at a relatively low altitude for the Alpine region at 1371 meters and therefore is used year-round. In our technological age, the pass has become a bottleneck for transalpine transportation. An ambitious construction project at a cost of $11 billion should solve this problem. Today, we will tell you about the construction of a new megatunnel under the Alps. Let's get started. In 1980, the total volume of transportation in transalpine routes amounted to 50 million tons, of which 55% was attributed to railway transport. By 2022, it had grown to 230 million tons. However, the share of railways had dropped to 31%. The increase in truck transportation across the Brenner Pass is a cause for concern. Approximately 2.5 million freight trucks pass through this route annually, which translates to 285 trucks per hour. Such heavy traffic causes air pollution, which is not acceptable to local residents. However, the existing railway line from the Austrian city of Innsbruck to the Italian city of Bolzano, built between 1860 and 1867, requires modernization. Additionally, its gradient reaches up to 2.5%, making train travel challenging. Due to the steep incline, trains can only reach a maximum speed of 70 kilometers per hour. The solution to this problem is the ambitious project of constructing the underground Brenner Tunnel. It will become one of the most important transportation links connecting the countries of northern and southern Europe, relieve the burden on the highway, and reduce the railway journey from Munich to Verona by half. The new railway line running through the tunnel will have a maximum gradient of just 1.2%, allowing locomotives to transport twice as much cargo. Planning for the construction of the Brenner Tunnel began as early as 1980, but no detailed design work was undertaken until the establishment of the international company BBT in 1999. It wasn't until 2010, when the tunnel's technical design and environmental impact assessment were completed, that construction could begin. The main problem that had to be solved was the issue of disposal of the excavated rock. During the construction of the Brenner Tunnel, experts estimated that more than 11 million cubic meters of rock would need to be extracted. On the Austrian side, a significant part of this material will be stored in the Inn Valley, which will eventually be turned into pasture. The Brenner Tunnel project, with a total length of 55 kilometers, includes two single-track tunnels with a diameter of 8.1 meters each, as well as an exploratory adit with a diameter of 5 meters, running beneath them at a depth of 12 meters. The southern portal of the tunnel is located within the territory of the Italian municipality of Fortezza, at an elevation of 747 meters above sea level, while the main northern portal is planned to be situated in close proximity to Innsbruck Central Railway Station at an elevation of 609 meters. The highest point of the Brenner Tunnel reaches a height of 794 meters. According to the project, the lines of the tunnel will be electrified with 25 kilovolt, 50 hertz alternating current and equipped with the European train control system. Near the main northern portal, there is a branching point that connects the Brenner line to a 12.7 kilometer tunnel on the Innsbruck Railway bypass. A crossing of the running shafts has been organized at this branch section. It is necessary due to the fact that the tunnel is designed for left-hand train traffic, which is adopted on Italian railroads, while Austrian railways follow right-hand traffic. In the rest of the tunnel, the tracks are spaced from 40 to 70 meters apart and are connected by transverse passages for evacuation every 333 meters. The total length of the tunnel's tracks is 120 kilometers, and the length of the exploratory adit is 61 kilometers. An additional 49 kilometers are allocated for service adits, which provide access to the tunnel and serve auxiliary functions. The exploratory adit is the most important component of the project. It will be used for drainage, ongoing infrastructure maintenance, and the installation of communication and electrical cables. The project includes the construction of 3 multifunctional life support stations, located at intervals of 20 kilometers, Innsbruck and St. Jodoc in Austria and Campo di Trans in Italy. The length of the station infrastructure will be 470 meters, and access to all 3 stations will be provided through tunnels designed for vehicular traffic. In the central hall of each station, there are ceilings dividing it into upper and lower levels. The lower level houses all the necessary facilities for emergency evacuations. On the upper level, there are technical facilities for controlling the tunnel's ventilation system. This level must be connected to the running shafts and ventilation ducts. Air will be supplied to the running shafts every 90 meters. When the tunnel becomes operational, approximately 320 freight trains and 80 passenger trains are expected to pass through it daily. The international company BBT is responsible for managing the project, established by the transportation ministries of Austria and Italy. The total project cost is estimated at $11 billion. Each of the countries contributes 30% of the expenses, while the remaining 40% is covered by the European Union. From the approval of the project in 2015 until the end of the calendar year 2022, the financial support provided by the European Union funds for the project has already exceeded 1.5 billion euros. This amount includes 303 million euros allocated to cover 50% of the exploratory adit construction costs and nearly 880 million euros to cover 40% of the costs for the construction of the 2 running shafts, with the remaining funds covering construction materials. By early December 2019, approximately half of the total underground excavations had been completed, covering 115 out of 230 kilometers. Construction is ongoing, with tunneling work taking place at 11 sites. The weekly average tunneling progress is about 500 meters. In total, 1,900 people from both the Austrian and Italian sides are involved in the project. One of the project's distinctive features is the construction of the exploratory tunnel in solid rock formations. A total of 16.7 kilometers of the exploratory tunnel have been completed between the construction sections of Tolfs Fons and Fons Brenner on Austrian territory. This has formed a tunnel section measuring 36 kilometers in length beneath the Alps, constituting 65% of the total tunnel length. To excavate the exploratory tunnel, Herneck proposed the use of a 1,800-ton, 200-meter-long tunnel boring machine of the gripper type with a diameter of 7.9 meters. After installation in an underground chamber at a depth of 3.5 kilometers in the mountainous region, it began its 15-kilometer journey from the Austrian Arenal Valley to the Italian border in September 2015. The completion of the Brenner Tunnel is planned for 2025. It is scheduled to be open for train operations in 2028, including the connection to the Innsbruck bypass, resulting in a total length of 64 kilometers for the Brenner Tunnel. It will become the longest tunnel in the world. Currently, the average train speed in the region barely exceeds 70 kilometers per hour, primarily due to the steepness of existing routes, which traverse significant elevations. The new railway line will fundamentally change the current situation. 400 trains will run daily on the new railway line at speeds exceeding 200 kilometers per hour. Travel time will be reduced by 2/3 accordingly. Currently, the world's longest railway tunnel is the Gotthard-Base Tunnel, opened in 2016, which cost more than $12 billion to build. The Gotthard-Base Tunnel, also located in the Alps at a depth of 2.3 kilometers, has a length of 57.1 kilometers. The length of the Brenner Tunnel will be 64 kilometers, 7 kilometers longer than the current record holder. Considering the limited infrastructure in major cities and the population density of the area, tunnels are considered by experts to be the most effective way to solve transportation problems. Their advantage lies in avoiding the inherent difficulties of bridge and viaduct construction, including land preparation, relocation of utility networks, and addressing various legal issues related to land rights. Tunnels are essentially unaffected by environmental factors, precipitation, and wind loads. Moreover, modern underground lines can operate without major maintenance for up to 50 years. In fact, the Brenner Tunnel is an example of how large-scale infrastructure projects can generate thousands of jobs during the implementation phase. Such projects are resilient to a wide range of external challenges, as demonstrated even during the pandemic. Additionally, as mentioned earlier, the tunnel is an important environmental project, as its operation will reduce carbon dioxide emissions by a factor of 21 per ton of cargo transported compared to using road transport. Write in the comments, would you like to take a train ride that goes 64 kilometers under the Alps? If you found something new and interesting in this video, don't forget to like it and subscribe to the Karo Show channel. Also, check out our previous videos. See you later.